Hello everyone. In today's session, let's discuss what are the ill effects of hard water in boiler. So the main use of water in industries is for two purposes. One, it is used in boilers for generation of steam, and another, it can be also used as a coolant. So if water is used in boiler for generation of steam, and if this water which is used it is hard water, then it can cause some problems to the boiler, which are also known as the ill effects. So there are main four factors which affect the boiler. The first is boiler corrosion, second is sludge and scale formation, then it is priming and foaming, and last is caustic embrittlement. So these are four ill effects of using hard water in boiler. Also, depending upon the pressure at which the boiler is operating, different level of hardness of water is permitted. Like if it is a low pressure boiler, the hardness of permitted water is above 40 ppm. If it is a medium pressure boiler, the hardness of water should be between 10 to 40 ppm. If it is a high pressure boiler, then the hardness permitted is 0 to 3 ppm of calcium carbonate equivalent. So in general, you can say as the pressure of the boiler increases, the hardness of the water which we are using in the boiler for generation of steam decreases. So higher the pressure of the boiler, lower should be the hardness of water. So let's discuss these four factors one by one, beginning with boiler corrosion. So what is corrosion in general? So corrosion can be defined as decay or destruction of a metal. So when the decay of destruction of boiler metal takes place due to presence of dissolved gases and impurities, it is called as boiler corrosion. So the boiler which we are using in industries, it is also made up of metal. Commonly used is stainless steel. So it is made up of stainless steel, contains the main quantity of metal which is iron, Fe. So this boiler metal can undergo corrosion due to presence of dissolved gases and impurities in the feed water. Feed water is the water which we are using in boiler for generation of steam. So this is boiler corrosion. So what are the causes for boiler corrosion? First, if it contains dissolved oxygen. If dissolved oxygen is present in the feed water, this dissolved oxygen will react with the metal of the boiler, which is iron, Fe, in presence of H2O, water, and we are heating the boiler for generating steam. So in presence of heat, it will get converted into ferrous hydroxide, which you can see is a precipitate. This ferrous hydroxide will further react with more oxygen to form rust. It is Fe2O3 dot twice H2. So rust is formed means the boiler metal is corroded. The rusting of iron is an example of corrosion. So if oxygen is present, it will react with the boiler metal to form rust. So how we can remove this dissolved oxygen? One method is by adding sodium sulfite, Na2SO3. It will react with oxygen present in boiler water to form sodium sulfate, which is water soluble salt, means oxygen is getting removed. Another is by adding hydrazine. N2H4 is hydrazine. It will react with the dissolved oxygen to form N2 gas, that is nitrogen gas plus water molecule. So in this way, the dissolved oxygen is removed. And the third method is by adding sodium sulfide. So if we add sodium sulfide, it will react with dissolved oxygen to form sodium sulfate, which is again a water soluble salt. And we know water is not hard due to presence of salt of light metal ions. So if water contains salts of light metal ions like sodium or potassium, it won't be hard. While water is hard when it contains salts of heavy metal ions like magnesium, calcium, iron, and so on. Another reason for corrosion of boiler metal can be presence of dissolved gas like carbon dioxide. So if carbon dioxide is present in water, it will react with water to form H2CO3, which is carbonic acid, and it is a weak acid. So we know metals undergo corrosion in presence of acidic or basic medium. So since carbonic acid is a weak acid, it will lead to slow corrosion of the boiler metal. So how we can remove this dissolved CO2? It can be removed by reacting it with ammonia. NH3 is ammonia. So carbon dioxide present in water will react with ammonia in H2O to form ammonium carbonate. So again, this ammonium carbonate is a water soluble salt and it won't be responsible for hardness of water. Third reason is hydrolysis of salt. So we know boiler corrosion will occur due to presence of dissolved gases or dissolved salts of heavy metal ions. So it can contain gases like oxygen and CO2. So we have seen till now how it will be responsible for boiler corrosion and what are its removal technique. The third is hydrolysis of salt. So if water contains weak base and strong acid salts like magnesium chloride, calcium sulfate. So these are the salts of weak base and strong acid. Like Mg is coming from magnesium hydroxide, which is a weak base, and Cl is coming from a strong acid, which is HCl, hydrochloric acid. So these are the salts of weak base and strong acid. Similarly, calcium sulfate, calcium is coming from weak base like calcium hydroxide, and SO4 is coming from a strong acid like H2SO4. So you can see these are the salts of weak base and strong acid. Then they are hydrolyzed at the boiler temperature and pressure to form strong acid. And this acid is going to corrode the boiler metal. If weak acid is there, it will lead to the corrosion of boiler metal but at a slower rate. While if a strong acid is formed, it will corrode the boiler metal at a faster rate. So if this magnesium chloride is present in water, it will undergo hydrolysis, means it will react with water at boiler temperature and pressure to form magnesium hydroxide and HCl. So it will undergo hydrolysis to form a weak base and strong acid. So you can see the hydrolysis reaction is actually the reverse of neutralization reaction. In neutralization reaction, a base reacts with acid to give you salt and water. So hydrolysis is the reverse reaction of neutralization. So this salt is reacting with water to form a weak base and a strong acid. So this strong acid which is formed, it will react with the boiler metal, which is Fe, to form FeCl2 plus hydrogen gases evolved. Now this ferrous chloride formed will further undergo hydrolysis, leading to the formation of rust. So again you can see FeCl2 is a salt of a weak base, or you can say a salt of a weak base and strong acid. So the Cl part is coming from the strong acid. So it will undergo hydrolysis. It is undergoing hydrolysis to form ferrous hydroxide plus again acid is formed. So this acid will again react with the salt of weak base and strong acid and it will continue the reaction. And what will happen once ferrous hydroxide is formed? This ferrous hydroxide can react with excess of oxygen to form rust. Again it is forming rust, which is Fe2O3 twice H2O. So means in general the corrosion of boiler metal is taking place if it contains salts of weak base and strong acid because they undergo hydrolysis. This is about boiler corrosion. Let's have a look at the second factor, which is priming and foaming. So let's see what exactly is priming and what is foaming. So priming can be defined as that when a boiler produces steam rapidly, some water droplets are carried along with the steam. This process of formation of wet steam is called as priming. So in boiler, we are converting the water into steam. We are heating the water in boiler to get converted into steam. But sometimes it can happen that while generation of steam, along with steam, some water droplets can get carried. So we call it as wet steam. And this process is called as priming. So this is the steam you can see in the image. And in this steam, it will contain some water droplets, which is priming. So what are the causes of priming? First, if it contains large amount of dissolved solids, then steam generation doesn't occur smoothly. Second, high transfer rate of steam in boiler compartment. If there's high speed of steam generation, then it can lead to priming. How we can prevent priming? So instead of using hard water, we should use soft water in boiler, means it will contain less dissolved salts. So priming can be avoided because priming is occurring due to using of hard water. Second, by maintaining low level of water in boiler. So if we maintain low level of water in boiler, then the formation of wet steam can be prevented. And third is avoiding rapid cycles of boiling and cooling. So avoiding rapid cycles and taking some break between it can prevent priming. Next is foaming. So what is foaming? As the name suggests, it is the formation of foam in the boiler water. You can see here there is a formation of foam on the surface of boiler water. So formation of persistent bubbles which leads to the formation of continuous foam on the surface of water is foaming. So what are the causes? If water contains some oil-like substances, it will lead to the formation of foam. Second, if it contains finely dispersed suspended material, means if it contains the impurities of suspended materials, then the steam formation will not occur properly. It can lead to the formation of foam. And third, violent agitation of boiler feed water and rapid flow of water inside the boiler and heat exchangers. So violent agitation is violent mixing. Okay, so in boilers, when we are converting the water into steam, the boiler is also rotating or agitation is taking place inside the water. The water has been circulated. So if it is a violent agitation, then it can also lead to the formation of foam. So how we can prevent foaming? Foaming can be prevented by adding anti-foaming agents which prevent foaming like castor oil. Second, by proper maintaining the routine blowdown operations, we can prevent foaming. So blowdown operations means frequently exchanging or replacing the water which is present in the boiler. So frequently replacing the water which is used in the boiler, we can prevent foaming. That means the water gets replaced. So every time we use another sample of soft water. So these are the ill effects of using hard water in boiler. We saw two ill effects in this session. One was boiler corrosion. Second is priming and foaming. The other two we will see in the next session. Thank you.